Okay, in this video, we are looking at an example of a series RLC circuit. This circuit has a resistor, a coil, and a capacitor connected in series. The resistor has a resistance of 100 ohms. The coil has a resistance of 32 ohms and an inductive reactance of 0.23 henries. And the capacitor has a capacitance of 45 microfarads. What we are looking for in this circuit is the current of the circuit, the voltage drop across the coil, the voltage drop across the capacitor, and the total VARs of the circuit. You can pause here and take a minute to draw all the triangles that you would use for this circuit and put down the information you know to begin with. That is the best way to normally start with these circuits, is to draw out a set of triangles and put down all the information that you know on them to start with. Once you've done that, once you have drawn out all your triangles and put down the information you know, your circuit should look something like this. The resistor of 100 ohms we know is basically just a horizontal line, because there is no reactance and the impedance and the resistance are the same value. The capacitor, once you have figured out the capacitive reactance using the formula X equals 1 over 2 pi FC, the capacitance of the capacitor should be 58.95 ohms, and that capacitor is basically going to be a vertical line because there is no resistance in a capacitor and the impedance and the capacitive reactance are the same value. The coil, once we've figured out the inductive reactance of the coil with the formula XL equals 2 pi FL, the XL would come out to 86.7 ohms and the resistance is 32 ohms. These are the values that we know. So to begin to find the values that we're looking for this circuit, we have to start with the impedance of the circuit. Those are the values that we have, or values for impedance of the circuit. So let us work on the total impedance triangle. To begin with, we can add all the resistances up that we have. The resistance of the resistor, resistance of the coil, to get an R total for the circuit, and that R total is 132 ohms. To get the net reactance for the circuit, we take the inductive reactance and subtract the capacitive reactance, because the capacitive reactance is a smaller number in this circuit. And the net value of reactance we get when we do that is 27.5 ohms. So now for the total circuit impedance, we know the total resistance and the net reactance. We can use Pythagoras' theorem to find the total impedance of the circuit, which should come out to 134.89 ohms. Okay, so we know the total impedance of the circuit, and now we can find the total current of the circuit, which is always a great value to have for a series RLC circuit. Total current equals E total over Z total, 120 volts divided by 134.89 ohms, which gives us a current of 0.89 amps. Okay, so we know the current of the circuit, and now it's very easy to go from one triangle to the next to find Other values in our circuit, again, we know that to go from my impedance triangle to my voltage triangle, all I need to do is multiply by the current. To go from voltage to power, all I need to do is multiply the value from the voltage triangle times current of the circuit. Will give me the same side of the power triangle. We can come back the same way, only we divide by current. To go from power back to voltage, I divide by I. From voltage back to impedance, I would divide by I. I can also go from impedance right to power by multiplying by I squared. So it's easy to use the current to move across the triangles or move from the power triangles back the other way, if we were only given power triangles for a circuit, let's say. Okay, so to find the voltage across the coil, I just need to find the impedance of the coil using Pythagoras' theorem. Z of the coil is 92.42 ohms. Once I have the Z of the coil, all I have to do is multiply by the current. Any side of the impedance triangle for the coil multiplied by the current will give me the same side of the voltage triangle. So 92.42 ohms times 0.89 amps will give me 82.25 volts. To find the voltage across the capacitor, I just take the XC, the capacitance, times the current will give me the same vertical side. All three triangles for the capacitor are just a vertical side because there is no resistance. So the voltage across the capacitor is 58.95 times 0.89 amps, which is 52.5 volts. So we have the voltage of the capacitor now. The value that we have left to find is total VARs of the circuit. The total VARs comes from my power triangle. To find the total VARs, if I take the net reactance times the current squared, I will get the total VARs of the circuit. So 27.5 ohms times 0.89 squared gives me a value for VARs of 21.98 VARs. Okay, that is all the values that we were looking for this circuit. Hopefully, using the triangles this way helps you to find the values you're looking for a little bit easier, a little bit different way than what the module shows. And the last thing I'll show you is a picture of the circuit with all values solved for, so you can look at any value you may have found out in this circuit and see if it agrees with what you found. So here's a picture of the entire circuit with all values shown on it. That's it for now.